Welcome to the Deep Dive, where we take your stack of sources and distill the chaos of information down to the essential insights you need. Today, we are tackling what has become really the ultimate test for any modern connected business. When the worst happens, systems crash, a network gets corrupted, a full-scale cyber attack hits, how quickly and how reliably can you actually stand back up? We're going deep into the world of business continuity and disaster recovery, or BC&DR, and we've got sources that, well, they expose some pretty alarming failures in current planning, but they also map out a path forward. We're talking revolutionary solutions like zero-touch endpoint recovery and how AI is moving DR from a reactive chore to a real predictive advantage.
And we have to start with the urgency. I mean, the threat landscape has never been more volatile. The risk of sophisticated ransomware, malware, state-sponsored hacking is just climbing dramatically in this hyper-connected world we're in. And what's truly shocking is that as the risk goes up, the preparedness level seems to be, well, failing to keep pace.
That brings us straight to the crisis in disaster preparedness. The statistics we reviewed they're not just bad. They suggest a real institutional failure to prioritize resilience.
Well, they absolutely do. When you look at the raw data, the numbers are deeply concerning. Our sources state that more than 77% of companies don't have a proper disaster recovery plan. Or, and this is the crucial part, they lack the resources to actually execute one. That's 3 out of 4 businesses just betting a disaster won't happen.
And when that bet fails, the consequences are terminal. If a major disaster does hit, 90% of companies say it had a high impact on their business, and over half, 54%, experience prolonged downtime. We're talking days, maybe weeks. And here's the Grim Reaper statistic, the one that should send shivers down every CEO's spine. 40 to 60% of businesses just never reopen after a major disaster.
So you have to ask, right, why? With these consequences so clear, why are companies still failing so spectacularly to prepare? It's not just a technical failure, it's procedural, maybe even cultural.
I think you've hit the nail on the head there. It's not always about denying the threat exists. It's about the sheer complexity of the traditional solution. Traditional DR planning is it's cumbersome. You're talking about massive upfront capital for failover hardware, duplicate PC inventories.
Exactly. And expensive dedicated backup storage facilities, not to mention the sheer human toil. Traditional DR requires so much labor just to implement, to test, to maintain the documentation. And let's be honest, that documentation is usually out of date the minute it's printed.
Right. It's instantly a legacy document.
And the recovery process itself is intensely manual and disruptive. It means these plans often fail to maintain true business continuity. They provide recovery, yeah, eventually, but not continuity.
That is a subtle but really important distinction, and we've seen organizations try to escape that complexity by moving to newer alternatives, virtualization, cloud services. Did that solve the problem?
Well, partially, but it really just shifted the pain points. The cloud filled the gap of expensive hardware, sure, but it brought its own challenges. Organizations started dealing with issues like failover latency, that delay between the primary system failing and the cloud replica coming online. They also had limited business functionality during recovery and, maybe most frustratingly, these unpredictable, skyrocketing cost structures. It was a trade-off, not a solution.
So if the traditional model is too expensive and complex, and the early cloud alternatives had these frustrating delays and costs, we need a complete paradigm shift. Let's unpack what might be the most disruptive innovation for the individual user: zero-touch endpoint recovery. We are talking about going from IT spending days or weeks fixing a corrupted PC to rebuilding a single system or even an entire remote workforce in minutes.
This is a direct answer to the Achilles heel of traditional DR, the individual endpoint failure. Caused by a corrupt OS, ransomware, even just a hard drive failure. These zero-touch solutions are designed to handle this remotely with absolutely zero technical expertise needed from the end user.
And when we say zero touch, we really mean restoring everything. It's not just the OS, it's all the user applications, specific settings, data, and critical security compliance profiles. The goal is that the employee logs back in, and it's like nothing ever happened. They just keep working.
And the mechanism behind this speed is where the engineering really shines. Traditional reimaging, it requires laying down a fresh OS, then you install applications, then you restore configurations and data. It's slow.
Right, it's a long sequential process.
But these zero-touch models, they fundamentally separate the OS layer from everything else. They do this by continually scanning the PC, discovering its precise configuration, and storing that information in a central database.
What's crucial here is the localized preparation. The system creates a dedicated localized recovery space on the machine itself. Think of it like a pristine emergency partition. And it populates it with all the known good sources.
And the genius part is that it continually validates the integrity of that recovery space. So if you get a new patch or a new application, the recovery space updates immediately.
That validation process translates directly into efficiency. Rebuilds are often done in under, 15 to 30 minutes. You eliminate costly desk visits, which is huge for remote workforces, and you get a full rollback capability that just sidesteps hours of human labor.
And the most immediate critical use case is, of course, cyber defense. If ransomware hits, you don't waste time trying to clean up the infection. You just eliminate the threat entirely. You rebuild the entire OS from a known good source. It's like the digital equivalent of burning the infected village down and building a clean one in its place, instantly.
And that links directly back to security compliance. These systems use compliance rules that are embedded in the recovery image, so they continually enforce security zero trust protocols automatically. Every recovery ensures the device is back to a compliant, secure state no matter where the employee is.
So Zero Touch masters the individual system failure, which is a massive leap forward. But that still leaves the sprawling network, the infrastructure, the thousands of servers. And that brings us to the scale problem and how the cloud is now tackling it through Disaster Recovery as a Service, or DRIS.
DRIS fundamentally revolutionized the financial model. Instead of sinking millions into hardware that just sits there idle, businesses only pay for the cloud infrastructure they provision, and they only pay the full recovery price if a disaster actually hits. That just dramatically lowers the barrier to entry for robust DR.
And it promotes simplicity. The goal has shifted from managing two separate data centers to just replicating your site with a minimal cloud footprint. This is often done with aggressive data compression and deduplication, so storage costs are tiny until they're actually needed.
The CIOs we researched kept coming back to this point about complexity. They want DR to feel like business as usual, not some massive special event. One person described legacy DR as a pebble in your shoe that always hurts, always complex, always costly. DRI aims to remove that pebble entirely.
And the real-world results are pretty compelling. Take the Sacramento Kings, for example. They implemented a cloud backup and DR platform in only 30 days. Their VP noted the value of the single pane of glass dashboard that makes management simple. And they successfully passed their quarterly tests, which included restoring a production server that went offline.
That 30-day implementation, that sounds phenomenal, but I have to ask, is that typical? Or is that the kind of marketing highlight that gives IT leaders unrealistic expectations? A full DR deployment in a month seems incredibly quick.
That's a fair point. For a typical enterprise with a lot of legacy systems, 30 days might be aggressive, but it highlights the core strength of modern DR, speed of deployment. A lot of the complexity is abstracted away by the provider, so you're not spending months racking hardware. You're spending days configuring replication agents.
We also saw sophisticated financial institutions adopting continuous data protection, or CDP. Automated Financial Systems, AFS, used a solution that provides a journaled, nearly real-time identical replica of their whole environment. What's the big advantage of that near real-time journaling?
The journaling is critical because it allows for granular recovery. Instead of a backup that happens, every 12 or 24 hours? CDP is constantly recording changes. This allows AFS to scale parts of their environment and, crucially, test individual customers or applications without that painful legacy approach. You know, the one where it was everybody goes or nobody goes. That huge coordination effort is just gone.
And the financial benefit of shifting away from these monolithic legacy solutions is immense. Molded fiberglass MFG switched to a hybrid approach using Veeam for on-prem servers and M365 email, and they reported a 7-figure savings. That tells me their old solution wasn't just expensive, it was a bureaucratic nightmare to operate.
It speaks volumes about the inefficiency of the old models, and this simplification is now heavily supported by advanced DRIS features. Beyond CDP, we're seeing extensive automated testing capabilities. You can test environments without disrupting production. And there's a feature called automated dependency mapping.
Let's pause on dependency mapping for a second, because that sounds like a massive headache saver. What does it actually do?
Think of it like a network cartographer. It crawls the entire infrastructure, locating every connection and dependency between systems. And why is that essential? Because when you have 1,000 servers, you need to know that the database server has to be running before the application server tries to boot. Otherwise, the recovery fails. This automates the correct server boot order sequence, which eliminates a huge area of manual error during a crisis.
That moves us logically into the layered defense you need for cyber attacks. We're seeing the emergence of cyber recovery as a service, or CALIF, which goes way beyond simple data restoration.
Yeah, CREAS is required because modern attacks, especially ransomware, are designed to contaminate your backups before they trigger the attack. You can't just restore the last backup and call it a day. You might be restoring the malware right along with your data.
So what does a robust CREAS model require then?
It needs three key components. First, curated recovery, the ability to find recovery points before the contamination happened. Second, forensic analysis, deep tools to understand the attack so you know exactly how the threat got in. And finally, a sanitary recovery space, a fenced-off sandbox environment to make sure the restored infrastructure is completely clean before it goes back into production.
And this is where the landscape gets really dynamic, because we're moving from reactive recovery into proactive prediction with the deep integration of artificial intelligence. AI is that next step in enhancing resilience, moving DR from fixing problems after they happen to anticipating them before they even manifest.
Absolutely. AI contributes across two essential areas: preparation and rapid response. In preparation, AI uses these sophisticated predictive models to analyze historical data and environmental factors. This can even include non-cyber risks like extreme weather, utility failures, or geopolitical risks that could impact supply chains.
So it makes resiliency planning adaptive. It's updating the plan in real time as conditions change instead of relying on a static yearly manual review.
Exactly. The AI model keeps the resiliency plan fluid and current. Then, in the response phase, AI automatically detects anomalies with incredible speed. For instance, it can spot data corrupted by ransomware and classify it as unusable. This allows technicians to just skip over those files and focus only on clean backups, which eliminates hours of manual file review.
And I imagine AI improves system integrity checks, too. It enhances boot detection accuracy, giving technicians more confidence that machines will actually bounce back after recovery. Well-trained AI models minimize false positives, which is just crucial in reducing total downtime.
But, and this is a big but, this advanced capability comes with significant caveats. Our sources really hammer home a major warning. AI relies entirely on having access to complete, high-quality data.
The old adage, garbage in, garbage out.
Precisely. If your corporate data is siloed or incomplete or just poorly managed, the AI models are going to produce unreliable predictions. Organizations have to establish robust data management practices before they can truly harness AI for DIR.
The challenges go beyond data quality, though. For a lot of organizations, especially mid-sized businesses, the high development and integration costs of these bespoke AI systems can be a massive barrier.
And that ties directly into the skills shortage. AI in the DR space requires this very rare blend of expertise. You need data science mastery combined with deep, low-level systems and infrastructure knowledge. Finding talent that spans both disciplines is incredibly difficult and expensive.
We also have to talk about the human element. There's always the risk of AI models producing false results that could complicate recovery. And, critically, an over-reliance on AI can reduce human oversight and critical thinking during a crisis.
And that brings us back to the fundamental limit of current AI. These models rely on pattern recognition from historical data. This means they excel at predicting known risks and detecting common anomalies.
But they struggle, by their very nature, with the unpredictable, high-impact black swan event. The zero-day attack, the novel infrastructure failure, the disaster that has no historical precedent in the dataset.
That being said, proactive investment in AI still provides a powerful competitive edge. By automating responses to the 99% of common disruptions, enterprises maintain continuity and are far better positioned to capture market share from competitors who are still manually reviewing corrupted file systems.
So what does this all mean for the IT leader listening today? We've covered a profound, necessary evolution. The painful, manual, and often failing DR strategies of the past are being rapidly replaced by integrated, highly automated systems. Systems that leverage flexible cloud infrastructure and the lightning-fast reliability of zero-touch endpoint recovery.
The central unifying goal across all of these advancements is speed and simplicity. The market is aggressively working to let organizations shift their recovery time moving from days or hours down to mere minutes, while significantly reducing the human element needed during a crisis.
We've discussed how AI excels at predicting known risks and detecting common anomalies using historical data, but if the greatest danger remains that unpredictable black swan event that AI models can't possibly anticipate, What organizational structure or what human oversight mechanisms should IT leaders prioritize right now to ensure resilience when the data and the models fail them? That's the critical discussion that needs to happen at the executive level.